Hello children, here's your science tutor Nishat. So previously we have seen that mixtures are of two types, homogeneous and heterogeneous. So today let us study something more about these mixtures. So firstly, homogeneous mixture is a one in which the substances are evenly distributed or uniformly distributed throughout. Right? Example was lemonade. So in this mixture of lemonade, the sugar particles and lemon particles are evenly distributed in water. The particles of sugar and lemon are not visible to us. They cannot be seen with naked eyes. They are very, very small. The particle size of sugar and lemon are less than 1 nanometer in size. And these particles of sugar and lemon cannot be separated from water by filtration, right? And such a homogeneous mixture in which the particle size is less than 1 nanometer in size is also called as a true solution or just a solution. So a solution is a homogeneous mixture. So when we look at the same example of lemonade mixture, the lemon and sugar particles which are present in less quantity are termed as solute. And the water which is present in high quantity in this mixture is called as the solvent. So with this we can conclude that a solution is made up of a solute and solvent. And when we try to pass a beam of light through a solution, the particles being very small will not scatter the beam of light. Hence, the path of light will not be visible in a solution. So now can we state the properties of a solution? Yes. Solution is a homogeneous mixture. The particles of a solution are less than 1 nanometer in size and hence cannot be seen with naked eyes. Since the size of particles is very small, they will not scatter the beam of light. Lastly, the particles of a solution cannot be separated by filtration. So this is all about the properties of a solution. Well children, it's not necessary that the amount of solute in a solution should be same all the time. No, the amount of solute can be varied. And depending upon the amount of solute present in a solution, they can be termed as either concentrated, dilute or saturated. So let's see these terms in detail. If the amount of solute is present in a less quantity in a solution, it is termed as dilute. And if the amount of solute is present in more quantity, it is termed as concentrated solution. And if the amount of solute is present in so much high quantity that it cannot be further dissolved in a solution, it is termed as a saturated solution. So these terms, that is dilute, concentrated or saturated, indicate the strength or the concentration of a solution. So the ratio of the amount of solute dissolved in a given mass or volume of solution is called as concentration. And chemists have given us the various methods to know or calculate the concentration of a solution. Here, let us see two of them. First method is mass by mass percentage of a solution, which has a formula, that is concentration of a solution equals to the ratio of mass of solute to that of mass of solution multiplied by 100. The second method is mass by volume percentage of a solution, which has a formula, that is concentration of a solution equals to the ratio of mass of solute to that of volume of solution multiplied by 100. So these are the two methods that we shall study to calculate the concentration of a given solution. let us solve an example. The question: a solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. So let us solve this. Given mass of salt, that is solute, is equal to 40 gram and mass of water, that is solvent, is equal to 320 grams. And we know that mass of solution is equal to mass of solute plus mass of solvent, which is nothing but 40 plus 320, which is equal to 360 gram. So the mass of solution is 360 grams. Now let us substitute the values in the given formula. Concentration of solution equals to the ratio of mass of solute to that of mass of solution multiplied by 100. So that is 40 divided by 360 multiplied by 100. So when we solve this, we get an answer which is equal to 11.11%. So this is how we can calculate the concentration of a solution. Well, the heterogeneous mixtures are also further of two types, that is suspension and colloids. Firstly, let us see what do we mean by suspensions. Suspension is a heterogeneous mixture in which the particles of solute do not dissolve. Instead, they remain suspended or dispersed in the solution. And the solute particles are bigger in size and hence are visible to our naked eyes. Example, sand water or muddy water. So when we add sand to the water, the sand particles will not dissolve in water. Instead, they are suspended, they are dispersed throughout in the water. And these particles of sand, being bigger in size, are visible to our naked eyes. And after some time, these sand particles will eventually settle at the bottom. And hence, the two distinct layers are visible. And thus, these two can be easily separated by filtration. So when the solute particles are suspended, they will scatter the beam of light. But once when they settle at the bottom, they will no longer scatter the beam of light. And thus the properties of suspension can be stated as: a suspension is a heterogeneous mixture. The particles of solute in a suspension are bigger in size and hence are visible to our naked eyes. The particles of solute in a suspension after some time will eventually settle at the bottom, and thus the particles of a suspension can be separated by simple filtration. Next, the colloids. Colloids are also a type of heterogeneous mixture in which the solute particles do not dissolve. Instead, they remain suspended throughout. But the point is, after some time, the solute particles will not settle at the bottom. They will always remain suspended throughout the medium. So that is the main difference between a colloid and a suspension. So the example of a colloid we can take is a milk. Milk is a colloid because the tiny fat globules are suspended or dispersed in the water throughout. These fat globules are so tiny that they cannot be seen with our naked eyes. But of course, they can be seen with the high resolution microscope. And after some time, these tiny fat globules will not settle at the bottom. Instead, they always remain suspended. And when we allow a beam of light to pass through a colloid, the beam of light is scattered in a colloid. And this phenomenon of scattering up of a light is called as Tindle effect. So these colloids always show the Tindle effect. So the colloid is made up of dispersed phase and dispersion medium. The solute particles that are dispersed are called as dispersed phase, and the medium in which it is dispersed is called as dispersion medium. So the properties of colloids can be stated as: colloids is a heterogeneous mixture. The particles of colloids do not settle down at the bottom after some time. Instead, they remain suspended throughout. The particles of colloids are very small, hence cannot be seen with naked eye, but can of course be seen with a high resolution microscope. The colloids is made up of dispersed phase and dispersion medium. Colloids always show the Tindle effect, and the particles of colloids cannot be separated by filtration. So that's all about the properties of colloids. And now, depending upon the physical state of dispersed phase and dispersion medium of colloids can be of various types. So here are a few of them. So children, let us continue this chapter in our next video.